set of indices, yes, index set, meaning that what is J? J is just set of some J1, J2, up to, don't know, JL. And of course, this J1 is larger or equal than 1, less than J2, less up to JL. JL is less or equal than M. We have some L specific indices. And then, okay, our matrix A was a matrix in R M times N. The matrix A was a matrix A1 transposed, A2 transposed, up to AM transposed. And now the matrix A with index capital J will be the matrix with only L rows. And this matrix AJ take the row AJ1, AJ2, up to AJL, and consider this. Okay, it means if you take an example, if the matrix A, let's say, be, I don't know, 1, 2, 0, 0, 1, 1, 0, 1, 1, 0, okay, 0, 1, 3, 0, 4, 5, I don't know, something like this. In what do we have here? 4 lines, 3 columns, and they can take J, for instance, 2 and 4. It means that they are interested in the second and the fourth row here, and therefore AJ will be 0, 1, 1 and 0, 4, 5, and it will be the matrix in R2, 3. Okay, clear the notation?
Yes. So what's the difference between the J, the upper J and the lower J, one with the sharper corner and one with the more rounded corner?
Sorry, upper corner.
So, when you say let J be a subset of this, and then you have the another J, is this the handwriting thing, or do they somehow differ?
It's the same J. It's the same J.
Okay.
The J is subset of this, and how it's look like, it consists of some indices. The set consists of some indices which are between 1 and M, and of course these are different indices. Yes, since okay, we are speaking about a set.
Yeah. Okay.
It's just a clarification what I mean if I said that capital J is subset of this. Okay. Clear?
Yeah. Thank you.
Okay. Okay. And now we will prove, using all this notation, we will prove the following lemma, which describes tangential cone. Okay, lemma says the following. Okay, let A be a matrix in R M times N, B is a vector in R M, D is a matrix in R P times N, and E is a vector in R P. And let capital X be the set of all Rx in Rn such that Ax is less or equal than B. And dx is equal to E. Linear equality and inequality constraints. And let some small x be an element of capital X, then what? Then the tangential cone of capital X and small x is equal to the set of all directions as in Rn, such that if we take the matrix A and consider only the rows corresponding to the index, to the active index set of X. Yes, again, this calligraphic A of X was the active index set. and you consider here this matrix with this index set, it means only the rows corresponding to active constraints at the point small x. And this multiplied by s should be less or equal than 0, and d multiplied by s should be equal to 0. This is exactly our tangential cone, and will be proved now. Is it clear what we want to prove? Is it clear the statement?
Yeah, yeah.
Okay. For all of you, again, questions are
We are not indexing D, right? Only A.
yes, only A. Only A. Yes. I mean, for equality constraints, we have no distinguishing between active and inactive. Yes, equality constraints, if you want, in a certain sense, are always active. Yes, they are equality constraints. Only for inequality constraints, they have these two possibilities: equal or strictly less. Okay. Okay, how the proof works. Okay, the set, they say let K be capital K be the set as in Rn a ax s less or equal than 0, ds equal to 0, and therefore they have to prove that tangential cone is equal to k. And as all the time, if they have to prove the equality of two sets, they have to prove two inclusions, yes? Okay, the first step we would like to show that tangential cone is subset of capital K, okay? Good. Um, okay, first of all, we know tangential cone is the closure, yes, of the set that we multiply lambda times y minus x, yes. Now let z be an element of this r plus r positive times x minus capital X. Yes, I recall that the tangential cone is the closure of this set. Yes. Let Z be an element of this. Okay, what does it mean? It means that there is some positive lambda and some y in capital X, such that Z is equal to lambda y minus x. Okay. Okay. Now we want to check that that at least every such point is an element of K. Okay, how to check this? Yes, we want to check that an element is an element of this K. How to check this? Okay, first of all, it's easier to check that d times z is equal to 0. Why? What is d times z? It is, okay, lambda dy minus dx. Okay, and now what we know, they know, of course, that dx is equal to e since x is admissible, and dy is equal to e since y is admissible, and therefore this is equal to 0. Clear? What is happening now?
Yes.
Okay. Now, what about the second condition? Okay, therefore we checked this condition. Yes, this condition for Z is fulfilled. What's about this condition? What happens if we take A with here active index set of X times Z? Okay, what's that? This is, of course, also lambda times this matrix times y minus this matrix times x. Okay, now question for you. What do you think? What can this say about this?
This is equal to B. Yeah.
This is equal to b. Okay, of course, also the corresponding components of b. Yes, since they have here exactly the active constraints, and therefore okay, they have exactly this. Yes, okay, since a of x is active index set. Is this clear?
Yeah.
Okay.
Yeah.
Okay. Question? Okay. What's about this? Okay, here they just know this is less or equal than b. Okay, of course, also in the corresponding components, just since y is an element of capital X. Okay. Okay, this is less or equal than b. This is equal to b. Therefore, the difference in every component is less or equal than 0. This guy is positive, and therefore the whole thing is less or equal than 0. Okay. Therefore, this is also true. Okay, therefore, what we checked that z is element of K. Agree?
Yes.
Okay. Now, um, now, what does it mean? What we make? We made we consider this set, that from this set, and check that this is a set of K. Yes, therefore we checked that R positive times X minus small x capital K. Now, 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 what we can say now that if we take now the closure of it, it will be still subset of capital K. Why? And the reason is here since capital K is already closed. Yes, if we have some subset of a closed set and we take closure of it, it will be of course also subset here. Yes, you can argue this way: the closure will be subset of closure, and the closure of K is K itself. Is it clear that K is closed?
Can we go back to the inequality argument? No.
Which one? Here.
Below E, yeah. So it is clear why A indexed with active set of X is equal to B stuff. Can we go back to the left part? Why is this less than or equal to B?
Since Y is an element of capital X.
Yeah.
And what does it mean, capital X? Capital X means that all constraints are fulfilled. Yes.
Oh, yeah.
And therefore, AX is for every element from capital X, AX is less or equal than B. Therefore, if Y is from a capital X, therefore AY is less or equal than B in all components and also in some special components. Yes.
Yeah. Okay. So there's differences at most 0, right?
The difference is less or equal than 0. Yes. And if you multiply it by a positive number, it is of course still less or equal than 0.
And since both A and D fulfill these 0 conditions, then Z is element of K. Is that the conclusion?
Yes, this said that if that is element of this, if that is has this structure lambda y minus x, then z fulfills with these both conditions, which means that then z is an element of capital K. It means we check that every element of this set is an element of capital K. Therefore, we check that this set is a subset of K. Agree?
And why are we checking its closure?
since the tangential cone is
Is closed.
defined is the closure of this, and therefore they are interested in the closure. Yes, and the argument is that okay, if A is subset of B, then closure of A is subset of closure of B. You can say it in this way. Okay, if you want, they can write it down in this way. It's probably, I don't know, probably clear. Okay, they have this, but this is equal to K since K is closed, and the fact that A is closed, if you want, you can check by yourself. It's quite easy. Okay, how to check that K is closed? You have to take a sequence in K. Okay, sequence S K as L converging to some S. And of course, if this sequence and the sequence is converging, then both things will be fulfilled also for the limit point, and therefore the set capital K is closed. Okay, clear?
Yeah, thank you.
And therefore, okay, and this is our T, and therefore we checked that T is subset of K. Now, yes, again, we checked this. Okay, good. Now the second step. Now we have to do it other way around. Now we want to show the what does it mean? I'll write it down. Means xs is less or equal than 0, and ds is equal to 0. Yes, this is what we have here. And probably again, this what is written here, what does it mean? It means that if we take a j transposed x, yes, j transposed s, this is less or equal than 0 for every j from a of x. Okay. 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 And now the claim is okay. We take such s, and I claim. My claim is that there is some delta small larger than 0, such that if we consider y equal to x plus delta s, this will be in capital X. Okay, the logic is again they're starting in point X and they're going in this direction S, and if we're going on just a little bit, we will stay in capital X. And I claim two things, and A, this calligraphic A of y will be subset of A of X. Index active index set of Y will be subset of index of active of the active index set of X. This is my claim. I will prove now this claim, and you will see in a moment that from this claim we will immediately see that S is an element of the tangential cone. Probably you can imagine already that if you have this, and then you will bring, you will be able to write S as y minus x times 1 over delta, and therefore you will see exactly what you want. Okay, but let us, yeah.
In the green, you have written that a j transpose times s is less than or equal to 0 for every j in the active set of indexes, right?
Exactly.
But isn't the definition of active set that for every index from that set, the aj times the s is equal to 0? Well, 0 in this case because 0 is b, right? So shouldn't that be an equality except of instead of less than or equal to?
Just a moment. I have a call. Just a moment.
Okay.
Sorry, I'm back. Yeah, I understand your question. You have to distinguish. Yes, what does it mean that J is an element of A of X? What does this mean? This means, as you said, of course, that AJ transposed X is equal to BJ. Yes, this is correct. But what this condition means that for all size J, for all indices, there they have this AJ transposed multiplied by S is less or equal than 0. Okay, this is the definition of K. Yes, the definition of K is that they take the matrix A, they take only the rows corresponding to the active indices of X, and then these rows multiplied by S should be less or equal than 0. Clear?
Yeah.
Okay. How to prove our claim? Okay, we have to check that if we add to X some delta times such a direction as fulfilling these two things, then it will be still admissible. Okay, what is the logic? First of all, concerning equality constraints is quite clear. Of course, if we consider dy, which is d times x plus delta s, which is dx plus delta ds, this is nothing to do. Okay, this is equal to E. This is equal to 0. Therefore, it is still equal to E. And therefore, okay, the equality constraint is fulfilled for y for every delta. Okay, do you agree?
Yes.
Okay, what's about inequality constraints? Okay, now they have to check inequality constraints. Yes, they are checking, again, what we are checking, we are checking y in x. Yes, we've checked equality constraint. Now we are checking inequality constraints. And for inequality constraints, we'll distinguish between I from active index set and not. Okay, let I be from A of X. Okay, what does it mean? As we said already, okay, here I've written it J. Okay, you can write J, you can write, okay, probably I will write J such that it is consistent. Okay, J. J, okay, J. Okay, let J be from AX. What does it mean? It means we know that AI AJ transposed X is equal to BJ. Yes, this is exactly the definition. Now, what happens at the point now Y? Okay, what's that? By the definition, it is AJ transposed X plus delta AJ transposed S. Okay? And here it's quite clear. Here we know this is equal to BJ. And this is the set is less or equal than 0. Okay, this is positive. And therefore, the whole thing will be less or equal than BJ. Okay? It means that for all J from A of X, the inequality constraint in Y is always fulfilled. Okay? Do you agree? Clear or not so clear?
Is X
Yeah,
an
it's clear.
element of
Sorry? Say it
capital
again.
X? Is X an element of capital X, or is it something different?
Say it again. What is element of what? I have not acoustically not understood what you're saying. Can you say it again, please, George?
Can you hear me now?
Yeah, I can hear you. Yes.
is X an element of capital X, or
Yes,
is
so
it
for
something
sure,
different?
for sure. Small x is off
Okay.
is all the time